I started Zoom. I'm recording on Zoom. I asked for the sign-in sheet. I have the handout here ready to go. For those of you who are on Zoom, if you did not already get it, I have the handout in the SI resources section in the Moodle page. And I think I'm recording, and there's no, I hope I remember, stuff, because I'm not kind of scatterbrained. Okay, so we're talking about op amps. Now, op amps are something that you will be studying more in electronics. I don't know, what book are y'all using in electronics? Does anyone have it? Yeah. Okay, so where I'm going with this is, it used to be that we covered op amps in Circuits 1, and then for a few years they kind of just went over it, just pretty briefly, but they went over it so they knew you were going to get it in electronics, but apparently didn't get it last year in Circuits 1. So what I'm doing here is what we used to do in Circuits 1.
That's Microelectronic Circuit 8th edition from Oxford University.
Okay. Is it a big white book? Does anyone know?
Yeah, for the first week of the semester, we've been pretty scattered. I don't think anyone's been up to the bookstore or library.
Is it like this?
It might be a new version of it.
8th edition.
Okay, so I don't know. I'll have to look it up and see. Okay, so that's not it. So since it's not exactly the same book I learned from, I'm not sure if your curriculum is going to be in the same order that ours was. When I took it, op amps was kind of near the end. And what you'll be doing with op amps is not the same as what you would do in circuits. So what I'm doing is just what you would do in circuits and not what you're going to do in electronics, which will be a little bit more of the details. So what an op amp does is you have some input voltage, and then your output voltage is related to that input voltage via some sort of, can we close the door? Some sort of gain, and depending on where you look, they'll use different letters for the gain. So on this first page here, these are the schematics that I got from Professor Manal when she taught the class. She used this, and then on the next page I have the ones that are from the circuits textbook, and you'll see in the circuits textbook they use the letter G for the gain, and here it's the letter A. But either one, what it's saying is that is what you multiply the input voltage by to get the output voltage. And so one thing you can do with an op amp, and we did this a lot in electronics too, is if you can match the op amp to one of these that I have here on the front page, then you can automatically know what it does without having to look at the circuit and figure out what it is. So for example, we have this non-inverting amplifier, and you can see one of the features of an op amp is this feedback. So you have the output here, and then you have that feeds back into the negative terminal of the op amp. Now, as far as I know, there's no rule for whether the positive or the negative it goes on top for the op amp, and you'll see it both ways. You just need to pay attention to which it is on the one that you're doing.
In electronics, it says an ideal. The teacher said in ideal amp conditions, V in and V out would be equal to each other. So
Yes.
in this case, the plus, V plus, and V minus would be equal to each other.
Yes.
So that means that V out is equal to V in, right?
Well, that would be true on the follower, and that's why A is 1. So yes. So on this one, V in equals V out, because as we're getting to, in an ideal op amp, VP, which I'll also call V plus, the same thing, V positive, in an ideal op amp equals V in, which I'll also call V minus, so I'll use both of those. In an ideal op amp, that's true. So in this follower op amp, you can see that if the plus and the minus are the same, then V in and V out are the same, and that makes sense because this is your gain, and you would say V out equals A times V in, or V out equals V in. So yes, that is true. Now on this one right here, so that you have the feedback, but you have the feedback on all of them. But this one you have these two resistors, and on this one you have a gain, and it is, well, it's going to be 1 plus the ratio of the two resistors. And so this is a non-inverting amplifier. It's called non-inverting because you see it's positive. And then you have an inverting amplifier, and that one is negative. And so the V out is going to be negative of what the V in is. But again, you would look at what you have and see if you can match it up to one of these. You have the summing amplifier, and the summing amplifier, it does not sum together exactly the values of the resistors here. If you look at what the sum, I mean, it doesn't sum together these voltages, it sums together based on the values of the resistances in R4. Now, notice if R1 equals R2 equals R3 equals R4, then all of these would be 1, and it would sum them together. Now, notice also it's called a summing amplifier, but you'll see this minus sign out in front. So it's summing them, but then making it negative. Okay, so those are some of the op amps that you will become familiar with in electronics. Now, I'll come back to the ideal op amp in a minute. I'll look at some more examples. So if you look, this again, we have the non-inverting amplifier, and so it has, notice we've got this resistor here, RS, that next to the source. So V in, also sometimes VS for V source. And so we've got RS right there that's doesn't end up being part of the gain. Oh, I need to remember to keep things in this green box. Okay. And how does that compare to our non-inverting amplifier on the first page? Well, it's the same, it's just written in a different way. So if I got a common denominator here, this would be R1 over R1 plus R2 over R1 equals R1 plus R2 over R1. And then if you look here, I think we've got our R1 and R2 switched, but it's the same basic idea. So we have a non-inverting amplifier, an inverting amplifier, and this one says inverting summing. The one on the first page was inverting summing. You have a subtracting amplifier, you have the voltage follower, and you have a non-inverting summing amp. So these are all just things that you can look at. You also, this one, it says differential amplifier. I copied this from the Manal's PowerPoint. It's not differential as in derivative. It's just a difference. So this one, I would call this difference amplifier. And you also have calculus. So you have an integrator, and the font didn't quite show up on this, so this should actually be an integral right there. And you do have a differentiator. And you'll notice the integrator and the differentiator have a capacitor in them. Okay, so that's just telling you, that's just kind of a reference that you have. We'll see how you can use those in one of the problems that we've got. Now I'm going to talk about non-ideal op amps. Most of the time you'll be dealing with ideal op amps, but a lot of what you do in electronics, and I don't remember specifically with op amps, but a lot of what you're doing is you look at the device at different stages, and so you will almost certainly be doing non-ideal op amps in electronics. In circuits, we don't do much with non-ideal op amps, we deal with all ideal op amps. I know in electronics lab, you do some non-ideal op amps. Okay, so we're going to talk about non-ideal op amps, do a couple problems with those, and then we'll do some problems with ideal op amps. Before I go on with the non-ideal op amps, let me pause and see if I have any questions.
I was just confused about the summing amplifier.
Yes.
How you get that equation from it.
Oh, well, we haven't talked about where the equations are coming from yet. After we do some of the problems, then, do you still have your circuits textbook?
No.
Okay, I can, if I don't know it off the top of my head, I can look it up and I can show you where it comes. I mean, we could figure it out. I have done the ones that we're going to do today, but after we do some today, you'll say, okay, that's the method that I would go about finding it.
Because it's just hard to like look at that and get any meaning from it.
Well, sure. Yeah, no, absolutely. That's why we're going to see how you interpret it. Yeah, that's what we're going to do.
Could you explain that, what are non-ideal, the difference between ideal and non-ideal?
I will do that. That's going to be the very next thing I do. Other question? Yes.
What? I don't get what the integrated amp or the differentiated amp.
Okay,
Like, what
so
does this do?
what it does, okay, so your in voltage, in circuits 1, we did all DC. And so our voltage was 5 or 12. So voltages now are going to become functions. And so you can integrate functions and you can differentiate functions. And so that's what those are doing. Now, not understanding where it comes from, again, that will make more sense after we've worked some problems. But, so, were you saying you don't understand where it comes from, or you don't even understand, was it not sure what it means to integrate or differentiate?
No, I was more thinking about like how you would use it in real life.
Okay, so I don't know anything about real life, but I do know, like in a lab, I can tell you what you would do. So you would have, you would generate some signal to be the voltage, and then you have your op amp, and then you read the output, and the output is you'll have the signal, and the signal will be the derivative or the integral of what the input function is. So you can set your input to be a sine wave, and then look at your output and see.
Oh, so it kind of like change the input to a differential or explosive?
Yes, that's exactly what it is. Yeah, cool. Right. Yeah, the first time I saw it, it's like, that's pretty cool. Yeah, so you take your input as a function, and it takes the derivative of it, or it takes the integral of it, and then you can see that on the output. And are y'all taking electronics lab right now?
Oh, yeah, because you said op-amp does math.
Yeah, op amp does math. Op amp does math. Yep. And so, and so you will be doing that in lab. Actually, I don't remember. You'll be using op amps in lab a lot, but I don't remember what. It's later in the. If it's the same course I had, it'll be later in the semester, and I don't remember if you're doing the calculus, but yeah, it does do math. And so the whole point of the op amp is to do some math on the input. It takes the input, maths it, and you get the output. Okay. Other questions? All right, so I'm going to stop.